Okay, so we're on question number 12, and we have circle H, and they tell us that the radius of circle H is 10 inches. So I know that the distance from the center to the circumference is 10 inches. I have a central angle here, which is 60 degrees, and if my central angle is 60 degrees, well, I know then the arc that it creates is also going to be 60 degrees. So notice, guys, here that I'm just marking up my test, right? They want to know what is the arc length of arc RS. They want to know how long this arc is, right? Well, I know it's 60 degrees long, but that doesn't actually tell me the actual size. Well, what I have here is a circle that has a radius of 10. And if I want to know how big this arc is, well, it's probably a good idea to know the circumference of the whole circle, right? That's probably a good idea. If you remember, the circumference of a circle is 2 pi r, which is 2 times pi times 10, which is 20 pi. So my circumference is 20 pi. Notice here, here's my circumference in terms of pi, right? And if I keep going, it comes out to be 62.8 inches, right? So my circumference is 20 pi or 62.8. So what do I know? I know that the whole circumference is how much? 62.8. And I want to know how much this little part right here is, right? Well, one way that I could do is I can set it up as a proportion, which is what I did here. I know that the whole circle is 62.8, and I don't know how big the arc is. I know that the whole circle is 360 degrees, and I know that the little arc is also 60 degrees. So here it is. I know that the whole circumference is equivalent to 360 degrees, and the little arc that I'm missing is equivalent to 60 degrees. And what I can do here, guys, is I can cross multiply, and it's going to give me x, and x comes out to be 10.467. Another way you can do it is you can take your circumference, which is 62.8, and multiply it times the percentage of the circle, right? The entire circumference is 62.8. I know that this arc is 60 out of 360, and when I multiply, you notice I get the exact same answer, which is 10.467. Now, when you look at your answers here, you're going to notice they're all what? In terms of pi, which means that I have to take my arc, my 10.467, and put it in terms of pi. How do I do that? I take my 10.467 divided by pi, and I get 3.33 pi. I get 3.33 pi. Again, when you look here, though, you don't see 3.33 pi anywhere, right? You see 10 over 3 pi, or 5 over 3 pi, or 10 pi, or 20 pi. Well, if you take 10 divided by 3, if you just put it in a calculator, you're going to get the 3.33 pi, which is your answer, which is choice A. Let's move on to question number 13. Question number 13 seems like it's a complicated question, but if you approach it using the rules that we talked about at the beginning, right? Draw a picture, input numbers. If they don't give you any numbers, put in your own numbers. Draw the second picture with the new numbers, and then solve, you'll be okay. So let's take a look here. They tell me that the ratio of the perimeter of this square, of square RSTU to WXYZ is 1 to 2. Notice here, they don't give me any squares, right? There are no squares. So what do? I draw my squares. I draw them. I got square number 1, and I got square number 2. And I know that the ratio is 1 to 2. So whatever these sides are 1, these are going to be twice as big, right? Then they tell me that the area of my first square, which is RSTU, is 25 square inches. So what did I do here? Give me 1 second here, guys. Let me take out some information here real quick that I should have taken out before. So what did I do? I drew my first square again, and they tell me that the area of it is 25 square inches. So here's my square, is my first one, and it's 25 square inches. That's the area, the space inside. Well, if I know that this area and the space inside is 25 square inches, then I'm going to know what the sides are. What two sides of a square, when I multiply them, give me 25? Well, it's going to be 5 and 5, right? Then they want to know, well, what is the area of the second square, right? Well, hold on a second. I know that this one has an area of 25 square inches, and it's 5 to 5. And then they tell me that the ratio is 1 to 2, which means that the sides, if the sides of this one are 5, then the sides of my second square is going to be what? They're going to be 10 by 10. Does that make sense? So I have my two squares. They tell me the area. They told me that the ratio is 1 to 2. Well, I find the sides, and I know then that if these are 5, then these are going to be what? These are going to be 10. And if I know that these are 10 and 10, well, then now I can answer the question. They want to know what is the area of this square. Well, 10 times 10 is 100. 10 times 10 is 100 inches squared. And we can see here that that is choice D, 100 inches squared. Again, guys, notice they didn't give me any picture. I drew my two squares. I put in my numbers. I had to do a little investigative work, but I just put in the numbers, and eventually I got the answer by drawing my pictures and putting in the information. Okay, let's move on to question number 14. Question number 14, they give me the equation of a circle here. They give it to me here. And guys, if you remember in class, we said that the equation of a circle comes from where? It comes from the distance formula, except that we don't have a square root sign here, right? We don't have the square root sign. And it's pretty simple. Here, I can see that I have an x of -1 and an x of +3. And if you remember in class, we said that the difference between the equation of a circle and the real center is that they are opposites. So if my x is negative here, my center is going to be positive. And if my x is if my y is positive here, my y at the center is going to be negative. So right away we can see here that we have 1, -3. So it's either choice C or D. Finally, remember guys that my equation of a circle doesn't have what? It doesn't have a square root sign, right? How do they get rid of, remember that square root sign we talked about? How do you get rid of a square root sign? Well, what you do is you square both sides of the equation, which means that this side here was already squared. Well, if this is squared, I'm looking for the square root. So if this is 25, the square root of 25 is going to be 5. My radius is going to be 5. So right away, it's going to be choice C. Remember, guys, the coordinates of the center are the opposite of the formula, and in the equation of a circle, the radius has already been squared for you. So just take the square root of that. And that's why I get letter C as my answer. Let's move on to question number 15. Okay. So here we have question number 15. Okay. They show me a figure, and they tell me in the figure below, they tell me that XZ is perpendicular, segment XZ is perpendicular to line ZY. So here's XZ, here is line ZY. They're perpendicular, making 90 degrees. I put that there. So what else do I know? Well, I know that this is 90 degrees here. So I know these are a linear pair, right? So I know angle 3 is also going to be what, boys and girls? 90 degrees. Okay? They want to know which is true. They're asking me the relationship of angles, if either they're complementary or if they're supplementary, or if this angle is bigger than these two added together, or if this angle here is equal to these two together, right? Well, remember that complementary means that the angles add up to 90, and that supplementary, the angles add up to 180. What else do we know about a triangle? Because we have a triangle here, right? Well, I know that a triangle has how many? 180 degrees. And knowing that information, I can proceed to answer this question. Well, first of all, I know that this angle here is 90 degrees, right? And a triangle has 180 degrees. Well, if this angle here is 90 degrees and a triangle has 180 degrees, well, then that means that these two angles here, angles 1 and 2, have to add up to how much? 90 degrees, because 90 and 90 give me 180, right? So I know then that if I add angle 2 and angle 1 together, they're going to be equal to what? To 90. And then that 90 plus the 90 gives me the what? The 180 that I need inside of a triangle. Okay, so let's take a look here. Choice 1 says angle 1 and angle 3 are complementary. Well, I know that this is already 90 degrees, and 90 plus something else, is that going to be equal to 90? No, it's going to be more than 90, so it can't be choice A. By the way, do you remember what we said the relationship was between two non-adjacent angles and the exterior angle? Remember, there's a rule for that. There's a rule for the two non-adjacent angles and an exterior angle, and I'll tell you what that is in a second, but let's keep going here. It says that angle 1 and angle 2 are supplementary. Here's angle 1 and angle 2. Are they going to add up to 180? No, I think we already established that a triangle has 180 degrees, and if this is 90, then these two are going to add up to 90, which would make angle 1 and 2 complementary, so it can't be choice B. Let's take a look at letter C. Letter C says that the external angle, angle 3, is greater than the measure of angle 1 plus the measure of angle 2. Well, I know that these are a linear pair, so if this is 90, then this is 90, so angle 3 is 90 degrees, and I know already established that if I add angle 1 and 2, they're going to be equal to 90 degrees as well. So is angle 3 going to be greater than angle 1 and angle 2 added together? No. As a matter of fact, angle 3, the external angle, is going to be equal to, right? This 90 degrees is going to be equal to the 90 degrees of angle 1 and angle 2 added together, which is why the answer is choice D. And the rule says, guys, remember that the external angle is equal to the sum of the two non-adjacent angles, right? So angles 1 and 2 are 90 degrees, and they're going to be equal to the external angle of 90 degrees because they are non-adjacent to that external angle. Let's move on to question number 16. Question number 16 says, what is the contrapositive of the statement below, right? If a triangle is isosceles, then it has two congruent sides, right? Well, guys, here's my conditional statement, P to Q, right? If this happens, then that will happen. That is a conditional statement. But the contrapositive is, remember, we flip them, we switch them, and we negate them. So I switch my letters. Instead of being P to Q, it's Q to P, and they get negated. That means that the hypothesis and the conclusion switch, and they also get negated. They become opposites. So obviously it says here that if a triangle is isosceles, then it has two congruent sides. Well, the first thing is I'm going to switch them, right? So I'm looking for the sentence that starts with if it has two congruent sides, right? Well, if it has two congruent sides, and it has to be what? Negated. So I'm just looking for something that does not have two congruent sides. So if you look at choice A, if a triangle does not have two congruent sides, oh, that looks pretty good. Are there any other ones that say if a triangle does not have two congruent sides? This says if a triangle has, so nope, that's not it. This says if a triangle, nope, that's not there. And a triangle has two, nope, not either. So pretty much the answer should jump out to you that it's A. If a triangle does not have two congruent sides, then it is not